As a kid, Ant-Man was the embarrassing superhero with the generic name. Like the Green Goblin, he just sounded like your little brother's action figure. Giant Man's name seemed generic. The girls would surely give me side-eye if I were an Ant-Man fan. But Ant-Man is far more terrifying than most people realize. I would rather be taken out by Wolverine or Hulk. At least it would be quick. The smaller Ant-Man gets, the more deadly he is, and the slower he can kill you. We saw a glimpse of Ant-Man's potential in What If, where he killed even the Hulk. However, the most unrealistic scene in that episode was when he flipped the Black Widow in that library, and when he made Hawkeye release that arrow without Hawkeye knowing. Can you guess why? Because long before he was able to move them, Ant-Man's fingers would have sliced through Natasha's and Clint's flesh. It's like trying to lift 20 pounds of Jell-O with your bare hand. You can do it, but your fingers slice through the Jell-O. If Ant-Man is so small that he can't be noticed, his fingers are finer and more dense than a dental hygienist's tungsten needles. The same for the flat of his hands. So, let's review this. At Ant's size, Ant-Man can't flip Black Widow because her flesh would tear. She would remain in the same place. He can flip Superman because his invulnerable flesh won't rip only if Superman doesn't resist by flying. He can flip Iron Man too, if he's not too heavy in his armor. He can't flip Hulk at all because Hulk weighs 1,000 pounds. But since Ant-Man can't tear Hulk's skin, he could otherwise flip him. Let's take a realistic look at Ant-Man's abilities, keeping the pitchforks at bay. This is a scientific exploration that won't merely pick apart problems with the physics. It will also point out power that most people don't associate with Ant-Man. First, let's address Ant-Man physics. We're made up of mostly space. Take a look at this atom. When you look at it, it's mostly space, but this animation doesn't represent the Bohr atom in its proper proportions. If a carbon nucleus were a millimeter across, the first electron shell would be 13 meters away. That's 3.5 highway lanes wide. Ant-Man's technology shrinks the space between molecules, allowing him to maintain his mass and his full-size strength at any size. I used to go by the notion that no mammal could maintain his body temperature at Ant-Man's size, but since he's lost no mass and is still made up of mostly space, maybe he can hack it. But since he can maintain his strength, if he can bench press 400 pounds as a full-sized man, he can do the same when he's the size of a mouse. Keep in mind that when you grab pliers or a wrench, the tool doesn't add any force to your work. It just concentrates your strength into a small area. Ant-Man could remove lugs from your car without a tool, but under these same rules, Giant Man shouldn't be able to. More on that later. Some weird things happen, especially with Ant-Man's weight. Since he's lost no mass, he should weigh the same, but apparently, somehow, he weighs less. He can climb on people without them knowing and be supported by furniture not designed to hold a running man. In the real world, there's no way the Wasp could fly with those tiny wings at over 100 pounds. Here, not only is she flying, but she's ripping off a metal vent grate as if it's putty. In the team-up with Spider-Man against Equinox, the smaller she shrunk, the stronger she became. In the real world, her tiny, powerful, dense fingers would have damaged that metal, like the putty she referred to. Ant-Man also retains his full-size momentum, despite his reduced weight, causing damage when he lands against things. But somehow, he doesn't seem to weigh as much as he does at full size. There is one hero who has the same powers as Ant-Man. Not Wasp. That's given. Not Black Goliath, Bill Foster, who appeared in the Ant-Man and Wasp movie. That's given. No, it's the Vision, who changes his density without changing his size. This calls into question the law of the conservation of mass, where in a closed system, matter can neither be created nor destroyed. The Hulk also gains mass out of nowhere. Almost any hero, villain, or monster who transforms does this trick. Ant-Man amazingly has the best explanation. But let's get under the hood here. At a half-inch high, he's 379,413 times denser than iron and 154,714 times denser than tungsten. Ant-Man, at Ant's size, should be harder than diamonds. Honestly, harder than adamantium. Nothing in nature would be as dense except the neutron degenerate matter of a neutron star, commonly called neutronium. Neutronium is not made up of mostly space, it's just neutrons packed together like talcum powder. 1 cc, or cubic centimeter of neutron star matter, would weigh approximately 480 million tons. 1 U.S. teaspoonful of neutron star matter would weigh approximately 2.366 billion tons. So this is far more dense than Ant-Man. To get intensely real-world, at about half his height, he would have the density of iron, making him no joke to mess with. Iron is not twice as dense as the typical human body. It's about 7.87 times as dense, but at half height, volume scales with the cube of linear dimensions. At 1/9 his normal size, he would be 92 times as dense as iron. At ant or mouse size, his 200-pound weight would cause him to sink into most surfaces, including hardwood floors and soil, until he hits bedrock. And once underground, he's trapped. He'd quickly suffocate or drown if he hits the water table. Depending on where he is, bedrock may stop him tens to thousands of feet down, while Ant-Man might have to sink several thousand feet to reach dangerous temperatures in most places, in areas with high geothermal gradients. Particularly in the volcanically active western United States, he could reach critically hot temperatures in less than 1,500 feet. But we will accept that somehow his weight decreases when he shrinks because plot armor. Speaking of suffocation, I did the math for 2 inches tall here. Ant-Man's oxygen intake would be severely limited. The human respiratory system is designed to process a specific volume of air, proportional to the body's surface area and metabolic demands. When Ant-Man shrinks, his lung volume decreases exponentially, while his metabolic needs, particularly during physical exertion, remain relatively high. His body is expecting 900 quintillion oxygen atoms to be dissolved into the blood with each breath. But those little lungs are only breathing in 25 quintillion. To place it in monetary terms, he needs $10 per breath, and he's only getting 2/100ths of a single cent. He might as well be holding his breath during combat. He'd have to grow often to replenish his oxygen. Now, let's discuss Giant Man. The common portrayal of him as having strength proportional to his size is scientifically flawed, and the opposite of the way his powers work when he shrinks. Ant-Man has regular-sized man strength when he's small. In the comics, he has gone up against Hulk a few times, and luckily it wasn't a contest. In this image, a real Hulk in the real world would have shredded Giant Man's throat. He should have regular-sized man strength when he's big, and Giant Man should not weigh more. He has not gained mass. He's just spreading out his existing mass. This should actually make him incredibly soft and vulnerable. A regular human could easily rip him apart. Roles would be reversed. We also have to discuss that humans just stop working well at around 10 feet tall. At 20 feet, our blood would fail to even circulate fully. At 30 feet, we'd weigh about 25,000 pounds, and at 65 feet, which Ant-Man bragged about, we'd weigh 250,000 pounds. We don't just multiply our weight by the height factor. The square cube law is why. As an organism increases in linear size, height, its volume, and therefore its mass and weight, assuming constant density, increase by the cube of that scaling factor. This brings us to Ant-Man's combat potential. At ant size, he should be bulletproof, thanks to the kinetic energy being spread across his small frame, similar to how a bulletproof vest spreads the energy of a bullet across your chest. Also, he should be harder than adamantium. He might also think faster, with all his neurons closer together and a shorter nervous system. An Ant-Man might seem to move his head quickly and instantly like a bird or a squirrel. On the opposite end, Ant-Man might be able to read your every move in detail, as if you're in slow motion. However, leverage doesn't translate to speed. The rotational velocity is based on the radius of the rotation. The shorter the radius, the lower the speed. So, a full-size fist that might land at 60 miles per hour or kilometers per hour might land at 1/4 of that speed and hurt 1/4 as much too. Even injured, you could probably outrun baby Ant-Man, but he can spring up to full size and chase you down for more. Which brings us to the Thanos scenario. Let's analyze the potential outcome if Ant-Man were to infiltrate Thanos' lower internal cavity and rapidly increase his size. If Ant-Man were to expand within the confined space of Thanos' lower internal cavity, the surrounding muscular structure would resist with significant pressure. The resulting force would likely expel and spaghettify Ant-Man in bloody fashion. It may be very uncomfortable for Thanos, but I just can't see it killing him any more than I can see it killing Hulk or Superman, or even Thor, who seems more human, but is extremely durable. This may or may not injure Thanos. For all we know, Ant-Man might only find a USB port down there. If Ant-Man were to expand within a less muscular region, deeper in, such as the colon, the potential for internal rupture would increase, but it's really dirty work as is. Conversely, expanding within Thanos' sinuses, if present, would likely cause Thanos significant discomfort, disorientation, and maybe even death, in at least allowing the Avengers to capitalize on the opportunity. Believe it or not, I left a ton on the cutting room floor this time. So what are your thoughts? Let me know in the comments. Please like, share, and subscribe.